We've continued to do some important work with distance formula and finding the length of segments, whether we're in the coordinate plane or if we are given points. Worksheet 2, we already had worksheet 1. This was done in class on Monday the 22nd, and I'm just going to quickly go through an explanation and answer key. You have your work in front of you. I'm assuming find the length of a segment. As soon as we see length, it is all about distance formula. I have my endpoints xy and my other endpoints xy. I'm going to use the method that I've shown you that Mr. Petticord introduced me to, just looking at these values in a table and then asking myself how far apart the values are. From 6 to 9 is 3 units. From -2 to 1 on a number line is 3 units. So the length of this segment is going to be the square root of the square, some of the squares built on those, or as those differences. This is going to be the square root of 9 plus 9, so this is going to be the square root of 18. I don't have a calculator in front of me actually to check that, or to find out what that estimate is, so I'm just going to leave it that way. I'm going to use the same method. Distance and length mean exactly the same thing to us here in geometry with our coordinate work. 4 and -8, I'm putting it in the table xy. 7 and -10. And then again, I'm going to ask myself, how far apart are these numbers? Between 4 and 7 is 3 units. Between -8 and -10 is 2 units. And again, I'm not worried about the direction or if these are positive or negative numbers, because when I square them, I would have the exact same result. -3 times -3 would be 9 as well. And -2 squared, or -2 times -2, would also be 4. So this one's about the square root of 13. I'm going to give you an opportunity to reassess, to be reassessed on this as well. Number 3, I know when this came up before, the point 11.6 lies on a circle. That means that it's somewhere on the circle. Let's just say that it sits right here. And what's the length of a radius of this circle if the center is located? So they give us this point in this center, and what we're really just doing is finding length, finding the distance using the distance formula again. So I'll make my table over here, x and y, 11, -6, -4, and -3, and then ask myself the question, how far apart are these numbers? There's 3 units between -6 and -3. Now going from 11 to -4, though, is going to be 15 units. The space between 11 and -4 is 15 units. So I've got 15 squared, and I've got 3 squared. Now, I don't have a calculator in front of me, but I do remember that 15 squared is 225 and 3 squared is 9. So that's going to be the square root of 234. You can figure out with your calculator if that's what you had. Well, you should have seen that if you wrote it as a decimal. Now, going into the coordinate plane. So we've got 2 different things going on here in the coordinate plane. We've got some problems that are going to be looking for us to find slope. And I just want to recall that slope is the m in our y equals mx plus b, and we can count and find that by doing rise over run. And then the rest of the problems, we have distance. Let me tackle those couple slope problems, number 5 and number 8 first. The slope from D to C. D to C here, I'm going to start at D and see what am I going to do to get down to C? I'm going to have to, and I said a word there, down. I'm going to have to go down 2. And that would be my rise. And to the right, let's see, 1, 2, 3, 4, 5, 6, 7. -2/7. And it would be appropriate just to leave it as -2/7 rather than, there's nothing I can reduce it to, and I don't want a decimal. Down 2 to the right 7. Let's go A to D. The slope of A to D. Well, this one's interesting. It's actually a vertical line. 1, 2, 3, 4, 5, 6, 7. The rise would be 7. The run would be 0. Anything divided by 0 is 0, and the slope of a vertical line is always 0. Let me go tackle those distance problems. Now, with the distance problems for A to D here for number 4, the distance A to D, oh, I actually had just counted that. I counted rise as being 7. The length of that would also be 7, the distance or length. How about from A to B? Now, I'm going to look at A to B a little bit differently. A to B right here is going diagonally in the coordinate plane. So what I'm going to have to do then is consider, I'm just going to build a right triangle. This would do exactly what the distance formula does for us. The difference between the x values is how far it is from this point to this point, and I do believe that's 7. Yep, 7. And then up and down is 2 here. From A down is 2. This is going to give me, I'm thinking about this as the Pythagorean theorem. A squared plus B squared equals C squared. And so what's going to wind up happening, where am I at? A to B. It's actually going to be the square root of those, that 2 and the 7. We're getting exactly the same thing as if we were to put the points, the coordinates, into the table this way, or if we were going to use the points and we went and did the entire distance formula. I'm just shortcutting around using this distance formula, both in the way I talked about the lengths at the top. Oops, that's subtraction, sorry. And the way that I'm approaching it here. This is going to be the square root of 4 plus the square root of plus 49, so that's going to be square root of 53 for the distance from A to B. Let me go grab the distance from B to D. Now B to D is taking us right across this. B to D aren't even connected. So I'm going to have to first draw in my B to D. There it is. I need to know that length, and I'm going to take a walk on a right triangle. Ooh, went too far. I'm going to take a walk around a right triangle here. Now, again, I'm focused on 1, 2, 3, 4, 5, 6, 7. I keep seeing this 7. Focused on the lengths of the right triangle that I've created. I'm looking for this length here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the legs of this right triangle that I created for the length of B to D is 7 and 9, so 7 squared plus 9 squared is going to give me 49 and 81, 50 and 80. It's going to give me the square root of 130 for number 7. And 2 more, the distance D to C. Interestingly enough, I already have D to C highlighted in there. D to C I had back here with, I did the slope of D to C, distance of D to C. Now, slope of D to C was negative 2 over 7. And that was rise over run. Take a look at how this D to C, I'm going to now draw in that right triangle, and I'm not going to worry about going up or down. I've got the 2 squared and the 7 squared. Remember, slope is a measure of steepness, whereas distance is how long. So these are 2 entirely different things. Oh, I saw that before. I should have known that was that answer from, it's parallel to, it's the same length as A to B. It was kind of redundant that I did that. Oh, B to C, count it. That one's 7. So you are going to have an opportunity to reassess. Again, this was worksheet 2. We did worksheet 1, and then I tested you out on how you did slope and distance. It didn't go so hot, so a little bit more practice in a video that you can look back at. Good luck.